Yeah. Testing, testing, 1, 2. Can you hear me? Hello? Testing, testing, 1, 2. I'll clip it on here. Can you hear me? Can you hear me when I have it like this, though?
Yeah, it'll pick up, and then if you're too low, this being loud in the room will pick it up as well. So it's like a 2 for 2, like a 2 for 2. Oh yeah, and then just say something. So let's see how it sounds.
Hello? Can everyone hear me? Yeah, it's not loud enough. Awkward position here. Can everyone hear me? Doesn't sound loud. Is that loud enough? Can everyone hear me? Yeah? Good? Alright. Alright, awesome. How's everyone doing? I know the session's like right after the lecture. I'm sure you had to sprint here. But clearly, I guess we don't have that many people here. That's alright. I think we'll go ahead and get started then. Alright, so let me know if you guys can't hear me, and I'll try like adjusting the mic. So this is SI Trigonometry final review. Just making sure that everyone's in the right place. And yeah, my name is Nick, and I will be guiding you through this. So here's the review that I posted on the Study Union website, on the WordPress site. I don't know if you guys had a chance to see it, but it is there. And let's go ahead and begin. So here's the first question. Starting out pretty simple here. This is just from section 1.1. And so we just have a triangle here, A equals 4. Alright, and then C equals 5. So we just need to find the length of B. So quite simply, what do we need to do here? What's the theorem we use here? Alright, excellent. Thank you. I'm going to try to make it a bit interactive so that it's not as boring, right? Alright, so 4 squared plus B squared is equal to 5 squared. So you have 16 plus B squared equals 25. So B squared is equal to 25 minus 16, which is equal to 9. And then take the square root of that. And this could be plus or minus since we're taking the square root, but since we know this is a length, because it asks for a length here, we know it's got to be a positive number. So this has got to be positive 3. Alright. Let's go on to number 2. So yeah, this is pretty easy at first, just want to cover all the bases. So here we just want to find the measure of supplementary angles, which measures 3x and 6x. So if an angle is supplementary, what does that mean? Excellent. All right, so they add up to 180. So we just do 3x plus 6x equals 180. degrees. So you get 9x equals 180. And then you do 180 divided by 9. It's going to give you 20. Alright, so that means that 20 times 3, we're going to have an angle that's 60 degrees, and we have an angle that's 120 degrees. So those are our two angles. Alright, any question about the first two problems? Alright, good. Let's move on then. Okay, so for this one, this is section 1.3, and so we want to find secant theta. So secant theta is the reciprocal of cosine, right? So we know that secant theta equals 1 over cosine theta. And we know that cosine theta is just adjacent over hypotenuse, right? Alright, so we know that we know that the adjacent angle, or the adjacent side of this is going to be here. Alright, but we don't have that, so we're going to need to find that using Pythagorean theorem once again. So 7 squared plus x squared is equal to square root of 74 squared. Alright, so we have 49 plus x squared is equal to 74. And then make sure I don't mess up my arithmetic. Subtract that, you get x squared equals 25. Square root, working with the length again, so we know that's got to be positive. Alright, so we have 5 here. So we know that cosine is 5 over square root of 74. Except we're looking for secant, so we basically just flip that. Alright, and that will be our answer. Any questions? Alright. So now, let's go ahead and find the value of tangent of 45 degrees. So, for this question, our unit circle will come in handy here. So, who remembers what tangent was in relation to sine and cosine? Excellent. Okay, so we know that tangent theta equals sine over cosine. Alright. And then we look at our unit circle. We're looking at 45 degrees. So we go to 45 degrees. And we know sine was the x or the y value? Y? Alright, good. So sine is associated with the y value, and then cosine is associated with the x value. Except in this case it doesn't really matter because they're both the same. So you just do, we know that it's going to be just square root of 2 over 2 over square root of 2 over 2, which is going to equal 1. Alright. Let's go ahead and move on. So now we want to move on to section 1.5. Kind of just blazing through the first chapter. Alright, so use the right triangle diagram below, and we know that alpha is equal to 58 degrees. We know C is equal to 22 feet. And we want to find B. Alright? So we can set up another trigonometric function here. So we can do cosine 58 degrees is equal to adjacent over hypotenuse, which is b over 22 feet. All right. Multiply 22 on both sides. I'll just leave out the feet for now. So cosine 58 degrees is equal to b. All right, and now we use our calculator to figure this out. So we do 22 times cosine 58. All right, and what did you guys get for this? You said 11.6? Okay, good. So it's about 11.6. And we can go ahead and round that to 12 feet. All right, so that would be our answer. All right. Just stop me if you ever need more time to write something down or something, and then we can go back. All right. So section 2.1. Determine the angle of the smallest possible positive measure that is coterminal with angle negative 426 degrees. So for this, we just want to like add 360 degrees until we get a positive angle, right? So if we add 360 one time, it's clearly not going to be enough. So we want to add 362 times. So essentially we just do that. And we end up with, what do we end up with? 294? Good, thank you. So 294 degrees. All right, so that was kind of an easy problem. All right, let's go ahead and move on to 2.2. So the terminal side of angle theta in standard position passes through the point at negative 1, 2, and we want to calculate the values of the 6 trigonometric functions for angle theta. So here we want to draw, it would help to draw a triangle here. So say we have a graph, and then it passes through the point negative 1, 2. So here we say negative 1, so this would be 2. So the point's about here. And we know this is the terminal side. We can just draw it like that. Alright. So we know that this is negative 1, and that's going to be 2 in there. So what we can do is, what we need to, well, first we need to find, I'll just put the triangle and put it here. This is negative 1, this is 2. We use Pythagorean theorem to find this point, or find the length of this. So negative 1 squared plus 2 squared is equal to c squared. So 5 is equal to c squared. Alright, and then we take the square root, and it means c is equal to just square root of 5. Alright. Alright, now to find the 6 trig functions, let's see, we have to do sine. Sine is equal to what? Is it opposite over adjacent, adjacent over hypotenuse, opposite over adjacent? I didn't hear you. What'd you say? Okay, excellent. So opposite over hypotenuse. So we have opposite over hypotenuse. So we look here, opposite is 2, hypotenuse is square root of 5. So 2 over square root of 5. We need to rationalize this to multiply by square root of 5 over square root of 5. And we end up with 2 square root of 5 over 5 for sine theta. Alright? Now, cosine theta, what does that equal to? Alright, good, thank you. So, adjacent over hypotenuse. So that's going to be negative 1 over square root of 5. Once again, we have to rationalize the denominator. So we get negative square root of 5 over 5. All I'm doing is just multiplying by square root of 5 over 5. Or square root of 5 over square root of 5. I kind of just didn't write it out. Alright, so let's go ahead and find cosecant. So cosecant is the reciprocal of sine. So it's just going to be hypotenuse over opposite. So we just take this and basically flip it. So we know this would just be square root of 5 over 2. Alright, for secant, it's the reciprocal of cosine. So we just take this and flip it, this one. Negative square root of 5 over 1, which is just negative square root of 5. Alright, and then we can find tangent. And tangent is opposite over adjacent. Oh yeah, sorry. So yeah, opposite over adjacent, so that's 2 over negative 1. So that's just going to be negative 2. And then for the last one, cotangent, it's going to be just the reciprocal of that, right? So negative 1/2. And those are all our trig functions for this problem. Alright, any questions there? Alright, moving on then. So if secant theta equals negative 2 and the terminal side of theta lies in quadrant 3, find tangent of theta. So for this, let's go ahead and draw a triangle in quadrant 3. So quadrant 3 is going to be this quadrant right here. So we know that secant theta equals negative 2. And we know that secant theta is inverse of cosine theta. Alright. So then what we're going to want to do is we know that therefore cosine theta is just negative 1/2. So we know that, just draw like this. So we have theta. Alright, we know that cosine is also, we know that it's adjacent over hypotenuse, right? So it would be negative 1, and then this is 2. And then we're finding tangent theta, so we need opposite over adjacent. So we need to use Pythagorean theorem here again. So negative 1 squared plus b squared is equal to 2 squared. Take a square root. And then b, we know, is going to be equal to a negative square root of 3. The reason for that is because we know that it's in the third quadrant, so it's going down. Alright, so Now to find tangent theta, we know that that's going to be opposite over adjacent. So that's going to be negative square root of 3 over negative 1, which just equals positive square root of 3. Right. Any questions on that one? All right. Everyone got it, or need more time? Yes, question? Negative square root of 3? Okay, well, we know that it's in quadrant 3, right? So that means that the y value is going to be negative. So we're going it down negative square root of 3 here, just like we went negative 1 here. And then the radius is just always going to be, or this hypotenuse is just always going to be positive. All right, no problem. Good question. All right, now we have number 9. So simplify the following expression if possible and leave all answers in terms of sine theta and cosine theta. So here we just want to work with some identities that we know. So we know that cosecant theta is equal to, we want to get pretty much everything in terms of cosine theta, or cosine and sine, since that's what it asks here in the question. So sine theta and cosine theta. So cosecant theta is just 1 over sine theta. And we know cotangent theta is cosine theta over sine theta. Alright, so let's go ahead and use that. So we can substitute those into here. 1 over sine theta, cosine theta over sine theta, and that is equal to 1 over cosine theta. Alright, so now what we do here is we can basically multiply, or we could multiply by the reciprocal of this, right? So we do 1 over sine theta is the same as, whoops, sorry about that, put an equal sign there by accident. Just going to let it cross that out. Times sine theta over cosine theta. So these will cancel, and we get 1 over cosine theta. So it's essentially just like a proof. Alright. I'm wondering if I made a mistake there and accidentally put the answer in. I don't know if that's how it was written, or if it just had cosecant theta over cotangent theta. I don't know, but the point is that that's how you would simplify it to this form. Alright. So let's go here. So use an appropriate identity to find sine theta and cosine theta if we know that tangent theta is equal to negative 4/5 and the terminal side of theta lies in quadrant 4. Alright, so in this case, what we want to do is we want to use an identity. So since it's asking us to use an identity, we can do it another way, but here we just want to focus on learning this identity. So we have the following one, where we know that tangent squared theta is equal to, tangent squared theta plus 1 is equal to secant squared theta. Alright. So we know that we can essentially just take this. So we substitute negative 4/5 into tangent theta. Plus 1 is equal to secant squared theta. And after calculating that, we ultimately find that secant squared theta is going to give us 41 over 25. So then what we do is we do cosine. We know that from here that cosine theta is equal to 5 over square root of 41. And then rationalizing the denominator, you get 5 square root of 41 over 41. And how we got to here is, what we did is we just basically took the square root, right? So this ended up being secant theta is equal to square root of 41 over 5, right? And then that just flipped over here. So now we have cosine theta. We want to find sine theta, and we could just use the Pythagorean identity to find that, right? So sine squared theta plus cosine squared theta is equal to 1. So we go ahead and plug this in. Although, I'm gonna make it simpler. Instead of plugging this whole thing in, it would actually be much simpler to just plug in 5 over square root of 41, because they're both equivalent. It's just this one would require more math. So, oh yeah, sorry, no problem. So sine squared theta plus 5 square root of 41 squared, and we know that's going to be equal to 1. So once we square this, we get sine squared theta plus 25 over 41 is equal to 1. Subtract that. Get sine squared theta is going to give us going to give us 16 over 41. Alright, and then we just take the square root, and then we find that sine theta, well, this could be plus or minus, because we're taking the square root, and sine theta is going to be equal to 4 over square root of 41, right? And we know that it's got to be positive because it said earlier in the problem that this was going to be in, we know that's going to be negative because it's in quadrant 4, so we know that sine is negative in that quadrant, right? Because we have a negative y value. Alright, and we could also rationalize the denominator here. So 4 square root of 41 over 41. Don't forget the negative sign. Make a note. Sorry, that kind of took up a lot of space, so it's kind of small. Hope you can see it. Can everyone see that clearly? It's negative 4 square root of 41 over 41. Alright. Anyone need more time? Can we move on? Alright. So let's find the measure in radians of central angle theta that intercepts an arc on a circle of radius r equals 1/5 inches with arc length s equals 1/20th inches. Alright, so for here, we're going to want to use our formulas that we have, right? So we know that theta is equal to s over r. That's something that we've hopefully memorized, right? And from that point, once we know that, it's simply a matter of just plugging it in and solving it. So let's go ahead and do that. And remember that this is in radians, this little formula. Bless you. Alright, so we have 1/20th over 1/5 is equal, same as taking this, bless you, and multiplying by 5. And we get 1/4 radians, essentially. Since this was actually inches, and those inches just end up canceling, and we're left with radian units. Alright, or you could write it as 0.25, it's the same thing. Alright, so this is just a conversion from degrees to radians type problem. So here we just take 170, and what do we multiply by to get radians? Alright, excellent, so pi over 180. And what do we get for that? $15.1? Okay, good. What about in a fraction form? Alright, excellent. So we get 29 pi over 6. Since the answer did ask us to leave it in terms of pi, so you would want to take note of that and not put it as a decimal when you are typing it in the exam. Alright, so number 13. Find the area of the circular sector given by radius r equals 6 centimeters and central angle theta equals 49 degrees. And round to 3 sig figs. So we have our formula for circular sector. A equals 1/2 r squared theta d. And since we are working with degrees here, it has that additional part to it where it's pi over 180 degrees, which simply just factors in the conversion. Otherwise, you could just do the conversion separately and then just have radians here without this part. Alright, so using that, this is another one of those problems where you, as long as you have the formula memorized, you should get it right. Yes? For this? No, he wouldn't give the formula for this. So this is something that you should definitely know. The only ones that he's going to provide, I'm pretty sure, are the product sum and sum product ones. So those are the 8 identities that you had. And I think he said he's providing the unit circle for the final. Does anyone know? Unit circle, yeah? Alright. Yeah, so he's being nice. You don't have to have it memorized, although it would definitely help. It would save you time if you know how to navigate a unit circle, you know. And for future math courses as well, like calculus, you have to have that memorized. So if you don't have it memorized now, I would definitely recommend if you're taking like high-level math classes later. Alright, so now we just plug and chug. So we have 6 centimeters squared here. Theta is 49 degrees. Multiply by pi over 180 degrees. And we ultimately end up with 15.4 centimeters squared. And that is rounded to 3 significant digits. All right. Any questions there? Okay. Let's move on to question 14. So now you want to find the angular speed associated with rotating central angle theta 216 degrees in time t equals 2 seconds. So once again, we need to know a formula for this. Does anyone happen to know the formula that would help us for this problem? And remember, it has to do with omega. You said theta over time? All right, excellent. So we know that omega, or angular speed, is equal to theta over time. And who remembers, is this in radians or is this in degrees? Radians? Okay, so this is going to be in radians. So we want to take this 216 degrees and convert it to radians. So when we go ahead and do that, we get 6 pi over 5. Alright? So then we know that omega is equal to 6 pi over 5 divided by 2 seconds. So our answer ends up being 3 pi over 5 radians per second. Alright. Move on to question 15. So find the distance s that a point travels along a circle over a time of 7 minutes. And we are given an angular speed of pi over 10 radians per second. And we know that the radius is 4.2 inches. Alright. So for this, we need to know that we need to be able to relate angular speed with linear speed. So does anyone know that relationship? Well, it was v over r, right? We know that omega, or angular speed, is equal to v over r, and v is just linear speed. So we can rewrite this like this. V is equal to omega times r. And then we also know that linear speed is equal to s over t. Alright, so we can go ahead and substitute this into here. So we know that s over t is equal to omega times r. We just put this right in there like that. And then since we're looking for s, we just multiply t on both sides. And so we get the following equation that we can use to find our answer. Alright, so now we just plug in what we have. So s is equal to omega pi over 10 radians per second times the radius of 4.2 inches, and then times time. Now, do we write this as 7 minutes, or what do we need to do? Seconds? Okay, good. So we have radians per second here, so we need to make sure our units line up, because we're given 7 minutes. So how many seconds is that? It's a pretty popular number, especially around, or at least was a couple days ago. Excellent, 420. So we got 420 seconds here. Alright, so 420 seconds, and that ends up being somewhere in the realm of 554.178 inches, which is about 554 inches, since the answer did ask to round to 3 significant digits, so this is 3 significant digits. All right, any questions on that one? All right. So using the unit circle, find the exact values of theta in radians where cotangent theta is equal to 1 on the interval 0 to 2 pi. So let's go ahead and, well, first let's figure out what cotangent theta is. We know that cotangent theta is just the reciprocal of tangent theta. All right. So knowing that, it doesn't really change anything since this is 1. So either way, it's going to be 1. So we just need to find where, essentially, when we do sine over cosine or y over x, it gives us a value of 1, and positive 1 at that. So where in the unit circle does that happen? Where do we have a positive cotangent? Positive 1 cotangent. First quadrant? Okay, good. And which angle? Pi over 4? All right, good. Anywhere else? You said, where did you say? 5 pi over 4? All right, so that's over here. So looking here, 5 pi over 4. All right, good. So we have a negative divided by a negative, which gives us a positive. Excellent. So pi over 4 and 5 pi over 4. Otherwise, if we look at 7 pi over 4, we get a negative value. And at 3 pi over 4, we also get a negative value. So it's pi over 4 and 5 pi over 4. So theta is equal to pi over 4 and 5 pi over 4. And that is within this interval. Otherwise, you could just keep going. Like if it was interval of 4 pi, say, then you would have to add on to that. All right. Now, I'm not sure if you'll be able to see this one. Can you see the numbers here? No? So basically, it wants us to find an equation for this graph. And can you see this is a 0.5? So we have 0.5, negative 0.5. This is positive 0.51, negative 0.5, negative 1. All right. So go ahead and zoom out. So looking at this graph, what kind of function does this look like? What kind of trig function? Sine? All right, good. So this looks like a sine function. And what is our amplitude in this function? One? All right, excellent. So amplitude equals 1. And is there any phase shift? No? No phase shift seen? Okay. Is the period modified? Yeah? I heard yes. All right. So what is the equation that we can use to find a period that's been modified? Anyone remember? It's, let me jog your memory. Period is equal to 2 pi over b, right? And now we know that what we have is the period. Because we know that this goes full cycle in that amount of, or in that length. And this right here is 0.25. It's half of 0.5 since we complete 2 cycles within that time. So 1 cycle is completed in 0.25. So to find b, we substitute 0.25 into the period. Multiply both sides. And we multiply b on both sides, you get 0.25b is equal to 2 pi, and then you divide 0.25 from 2 pi, and you end up with, or essentially 2 pi divided by 1/4, right, or multiply by 4, so b is essentially 8 pi. Alright? So now knowing that, the amplitude hasn't been modified, it hasn't shifted up or down, hasn't shifted right, it just has a different period. So now we can just write the equation, because it looks like a sine function, because we know the origin starts at 0, or I mean the graph starts graph goes through the origin. So we get sine of 8 pi theta. Or, I guess in this case, since we have an x value there, it would actually be sine 8 pi x. Eight pi? Oh yes, okay, so what I did is essentially, so this was 0.25 is equal to 2 pi over b, and then you have 0.25b equal to 2 pi, and then I just divided by 0.25, and 0.25 is just basically 1/4, right? Sorry. 0.25 is basically just 1/4, so this is like saying 2 pi times 4, which equals 8 pi. Does that make sense? All right. Any more questions? All right. So now, let's state the amplitude, period, and phase shift of the following function. So y is equal to -3 cosine of 5x plus 4. So here, what is the amplitude in this function? 3? Okay, good, thank you. So amplitude is 3. And now to find the period and the phase shift, what we want to do is factor out a 5 from here. You want to factor out the coefficient of the x value. So let's go ahead and go with that. Go ahead and make this a bracket. So 5x plus 4/5, like so. And once we do that, whatever is the coefficient of the x value inside this function is got to be b. That's b. So in order to find the period, we have to use that equation that we used earlier again. Period is equal to 2 pi over b, which is 2 pi over 5. So that's the period, 2 pi over 5. We can't simplify that one any further. And as for phase shift, we use 4/5 as our phase shift. And is this 4/5 to the left or to the right? Left? Okay, good. So this is 4/5 to the left. Or you can write it as just -4/5. Although it's going to depend on the question, because sometimes they have a little box where you just select to the left or to the right. If you don't have that box, then you have to use negative or positive signs to indicate which direction. And remember that it's going to be the opposite of the sign you see here. So when it's inside these parentheses, if it's positive, it goes to the left, or negative. If it's negative, then it goes to the right, or it's positive. Right? So number 19. To determine the period and phase shift of y is equal to 10 tangent of 10x. So here, we simply use a similar equation, except is it to find the period of a tangent function, is it 2 pi over b or is it something else? You said it was just pi over b? Okay, good, thank you. So it's pi over b. Because essentially what happens is what's up here in the numerator is the period of the function. So you know that the period of sine is normally 2 pi, so that's why we have a 2 pi there. Period of tangent is pi. That's why we have pi. Alright, and b is just equal to 10. So we know our period is just pi over 10. As for phase shift, there isn't one. Alright. Let's move on to 5.1. So simplify the following mess of trig functions. Alright, so what we want to do here is find a difference of perfect squares, right? Since this is a difference of perfect squares, so we can just use our algebra knowledge to work through this problem. So this becomes 1 minus cosine squared x, 1 plus cosine squared x, alright, and then we have 1 plus cosine squared x, so now we have these cancel, and we're left with 1 minus cosine squared x. Is that the final answer? No? So what would the answer be? Sine? Alright, good. So we're using the Pythagorean identity, right? So we know that sine squared x plus cosine squared x is equal to 1. And then when you subtract cosine, you get 1 minus cosine squared x. So our answer just ends up being sine squared x. Alright, good job. So question 21, we want to simplify the following expression. And so to go about this, we want to use the identities we know. X is just equal to cosine x over sine x, cosecant x is equal to 1 over sine x. So let's substitute that. So we get cosine squared x over sine squared x all over 1 over sine of x minus 1 over sine of x. So this is essentially, or dividing by 1 over sine of x is like multiplying by sine of x. So we get the following. You know that this sign would cancel. And we're left with cosine squared x. And these will have the same denominator, right? Since we cancel the square, or we cancel one of the signs down here. So they both have a common denominator of sine of x. So it's just cosine squared x minus 1 over sine of x. Alright, and now using our Pythagorean identity again, we can just look back here. So it was, we have sine squared x is equal to 1 minus cosine squared x, but in this case, it's cosine squared x minus 1. So it's actually just the opposite. So we have to add a negative sign in there. So this ends up being negative sine squared of x over sine of x. That cancels. Final answer is going to be negative sine of x. Any questions there? All right. So find the exact value of sine of pi over 12. So here we're going to want to use an identity. Since we know that pi over 12 is not in our unit circle, so it's not something we just look at and find the answer to. This one we can use, since this is from 5.2, the following identity will work. My pen's dying. So an angle that we could use, if we think about pi over 12 where it is, it's going to be like somewhere here. So it's going to be half of pi over 6. So if you take pi over 3 and subtract pi over 4 from it, you get this little amount, and that should be pi over 12, right? So we'll use pi over 3 minus pi over 4. And we're saying the identity was sine of a minus b to sine a cosine b minus cosine a sine b. Alright, so therefore we get sine pi over 3 times cosine of pi over 4 minus cosine of pi over 3 and sine of pi over 4. Alright? So from here we can just find each individual value. So we know that sine at pi over 3 is going to be the y value. Sine at pi over 3 is square root of 3 over 2. Cosine at pi over 4 is square root of 2 over 2, as is sine. Alright, so moving this down, so we had square root of 3 over 2. And then we had square root of 2 over 2. Yeah. And then cosine at pi over 3 is 1/2. Sine at pi over 4 is square root of 2 over 2. Alright, so we get a radical times a radical, so we just multiply whatever's inside. So that's square root of 6 over 4 minus it's dying. Minus square root of 2 over 4, and they have a common denominator. So we get square root of 6 minus square root of 2 all over 4. Alright, it seems that the end of this pen's life has come, so I need to find another pen. Just check real quick. It seemed that I only have one pen. Didn't have a pen I could borrow? Yeah? Thank you, sir. Appreciate it. Alright. Sorry about that. Alright, so let's move on to question 23. Alright, so use a double angle identity to find cosine 2x if tangent of x is equal to 12 over 5 in the interval of pi to 3 pi over 2. So in this one, let's first determine the identity we need to be using. So we have a double angle identity, so cosine 2x is equal to 2 cosine squared x minus 1. Alright, and so this identity involves cosine x, so we need to find cosine x using tangent x equals 12 over 5. So this is in quadrant 3, so let's go ahead and make a triangle in that quadrant. So tangent we know is opposite over adjacent, so that means our opposite is 12. So this is negative 12, and this is negative 5. We know it's in quadrant 3, so these are negative values. And now we use Pythagorean theorem to find the hypotenuse. Alright, so 25 plus 144. Add these together, you get 169 c squared. And we find that c is going to be equal to 13, right? Alright, so cosine of cosine x is equal to adjacent over hypotenuse, which is negative 5 over 13. And now we use that and plug it into the identity. Over 169. And I simply just converted 1 to 169 over 169 to have a common denominator. And this ends up giving us negative 119 over 169. Yep, no problem. All right. Any questions there? All right. So use a half-angle identity to find sine x over 2 of tangent x is equal to 60 over 11, and it is in the interval of pi to 3 pi over 2. So we know that's quadrant 3. So let's go ahead and figure out the identity we need here. This is a half-angle identity that we're going to be using, so that is sine of x over 2 is equal to plus or minus square root of 1 minus cosine of x all over 2. Alright, so now what we want to do is first find what cosine of x is, as we did previously. Since we're only given what tangent is, so let's draw a triangle again. Drawing triangle is just always helpful because, you know, it gives you that visual to help aid you. So once again, opposite over adjacent. It's negative 60. This is negative 11. Pythagorean theorem. And then I'm just going to go ahead and skip ahead to what C was. So C is equal to 61. Alright. So going from there, cosine of x is equal to adjacent over hypotenuse, which is negative 11 over 61. Now we can use our identity. And then 1 minus negative 11 over 61 over 2. Alright, and now what we want to do is find a common denominator there. So we end up with, basically this becomes 61 over 61. And then you're going to add an 11 to that, so that's 72 over 61. Divided by 2. And 72 over 61 divided by 2 is just going to be equal to 36 over 61. Alright, and then we have to decide whether it's going to be a positive or a negative value. So we have x over 2, but we're given the interval for x. So what we need to do is divide that interval by 2 in order to get the interval for x over 2. So it becomes pi over 2 and 3 pi over 4. And that's going to be in the second quadrant. And we know that in the second quadrant, sine is a positive value. So positive square root of 36 over 61. And we can simplify this further. So this becomes 6 over square root of 61. Rationalize the denominator. You get 6 square root of 61 over 61. Any questions there? Yes. The 36? Oh, well, 72 divided by 2 is 36. All right, well, I can write it out. So 72 over 61 times 1/2, right? So we're dividing, because we take 72 over 61, we just multiply 1/2 essentially. And then 72 divided by 2 ends up being 36 over 61. Oh yeah, sorry, couldn't see it. Does that make sense? Are you still confused about that, or you got it? Okay, good. So this is just like a little side note. All right. Let's go to 25. So write the product cosine 7x over 3 cosine 14x over 3 as a sum or difference of sines and or cosines. So looking at this looks quite similar to an identity we have. Which is cosine A cosine B is equal to 1/2 cosine of A plus B plus cosine of A minus B. Now this is one of those identities that's given, so this is one of the product to sum identities. So this is not one you need to memorize. All right, so essentially we can write it like so: 7x over 3 times the cosine of 14x over 3. And that's going to be equal to 1/2 cosine of 7x over 3 plus 14x over 3 plus cosine of 7x over 3 minus 14x over 3. Alright, so now it's just a matter of simply simplifying this. So 7x plus 14x is going to give us 21x, and 21 divided by 3 is going to give us 7. So it's just cosine 7x. And then we get 7x minus 14x. So that's going to give us negative 7x over 3. Now is this our final answer? No? Why is it not our final answer? You said cosine is even? Alright, excellent. So cosine is an even function. So since we know that's an even function, we know that that this negative can just be taken out. So when you have a negative on the inside on an even function, it's basically just goes away. If it was an odd function, then you can move that negative to the outside. So if this was like, say, sine, this would become minus sine of 7x over 3. All right? You guys want to take a little short couple-minute break, or do you want to keep going? We good to keep going, or what? Not getting any feedback. No. Yeah. All right. Well, just keep going then. All right. So evaluate the expression exactly if possible. If not possible, then state why. So in this problem, we have an inverse sign and then just a regular sine function here, and this is the sine of negative 11 pi over 10. You can see it? Yeah. Okay. So looking at the inverse sine, what are the intervals for which we have those inverse functions, or for an inverse sine specifically? Which quadrants hold values for the inverse sine? So 1 and 4? All right, good. So we know that for a sine function, for inverse sine, we have quadrant 1 and quadrant 4, for which this is true. So looking at negative 11 pi over 10, because essentially these signs would cancel, but we need to make sure that this number in here is within this interval. But negative 11 pi over 10 is somewhere, because if you think about it, negative 10 pi over 10 is the same as negative pi. So negative pi is over here, so negative 11 pi over 10 is somewhere here. So that doesn't fit. So we need to find an angle that's here, essentially, because this is sine, so sine is going to be the same because it's the y value when we move horizontally, because our y value doesn't change when we move horizontally. So this is one of those problems where you can use like the area or the angle of this slice, because if you know this slice, you know this slice, right? So what is the angle for this slice? Anyone know? Essentially what we could do is just, this we know is negative pi. So we could do negative 11 pi over 10, and we can subtract from it negative 10 pi over 10. So we're essentially adding a 10 pi. So we end up with pi over 10. So this angle right there is a pi, like that size of that slice is pi over 10. And we know that from there that this is also pi over 10. So essentially we have, this is negative 11 pi minus 10 pi. This ends up being negative pi over 10 here. But the reason for that being is just because in this case we're going clockwise. So you know when you go clockwise it's a negative value. But here it's counterclockwise. So when we go counterclockwise it's a positive value. So it's pi over 10. But if that confuses you thinking of it that way, you could just basically think that, yeah, this slice is going to be pi over 10 because the difference between here and here is a pi over 10 difference. So this is pi over 10. So we know that our answer is pi over 10. Any question on that one? Okie dokie. So let's go to 27. Now evaluate the given expression exactly, if possible. If not possible, then state why. So here, what we have to do is make sure that this number is in the range of the sign or in the domain of the inverse. So, what is the range of sign? Negative 1 to 1? All right, excellent. So, range of sign is negative 1 to 1. Now 1.2 is clearly outside that range, so this actually is undefined. Right? So it's undefined because 1.02 is outside the range of sine of x. Or if we were to draw the inverse sine function, it's also outside the domain of that one. Alright, so let's move on to 28. So evaluate the given expression exactly as a fraction. So here we have tangent of inverse cosine of 5 over 8. So here we know that in this case we can draw a triangle here, right? So cosine 5 over 8, cosine is positive. And for an inverse cosine function, which quadrants are we working with? For inverse sine, we have 1 and 4. What about cosine? 1 and 2. Okay, good. So for inverse cosine, it's either 1 or it's 2. And in this case, it's a positive number, so we know positive x, so it should be 1. Alright, so cosine is adjacent over hypotenuse, right? So here's 5, and here's 8. So now we want to find the y value. So we can use Pythagorean theorem. (64 minus 25) is going to give us 39. So b equals just square root of 39. And we know that it's got to be positive because we have a positive y value here, right? Alright, so that's square root of 39. So now we can go ahead and use this to find tangent. So we know that tangent is opposite over adjacent. So opposite is square root of 39. And adjacent is 5. So that is our answer. Any questions there? All right. let's take a quick 5-minute break. Use the restroom real quick. All right, everyone ready to continue? All right, so question 29. So solve sine of 2 theta equals, excuse me, negative 1/2 exactly over the interval 0 to 2 pi. So for this problem, what we can do is basically, you know how from algebra, if you have like log of x is equal to log of 2. Essentially what we could do is we could just like cancel out the logs, because anything that's whatever's in here has to be equal to whatever's here. So we could apply that exact same principle to this question. So we want to find where sine theta is equal to negative 1/2, so we can have a sine. So we know that sine is equal to negative 1/2 in the third and the fourth quadrant, so that's where y is negative. So negative 1/2 at 7 pi over 6 and also at 11 pi over 6. Alright, so we have does it make sense how we got to that step? Because essentially sine of 7 pi over 6 is equivalent to negative 1/2. So I basically use a substitution there. Same thing for here. So going from there, what we can do is just cancel out those signs. Get 2 theta is equal to 7 pi over 6. And we also know that the answers are going to repeat, right? And they're going to repeat every 2. It could repeat maybe once or twice or 3 times, as long as it's in the interval. This one, same thing. Now we want to divide by 2 since we're looking for theta. So theta is equal to 7 pi over 12 plus just n times pi. And we have 11 pi over 12 here plus n pi. Alright, and now we want to find out what actually fits in our interval 0 to 2 pi. So let's figure out how many times we can add pi. Say we can add pi 0 times, we get 7 pi over 12. Because essentially our cutoff is 2 pi, which is the same thing as 24 pi over 12. So once we get to 24 pi over 12, that's when we don't have any more answers. So we know that 7 pi over 12 is one of the answers. Let's see if we can get any more for this. So say we add 1 pi. 1 pi is like 12 over 12. 7 plus 12 is equal to 19. So 19 pi over 12 also fits. Can we add another 12 to that? Well, if we add another 12 to that, we're going to get 31 pi over 12, which is over our limit of 24 pi over 12. So no more answers there. Looking here, 11 pi over 12 fits in our interval. If we add pi, 12 over 12, 11 plus 12 is equal to 23 pi over 12. And obviously if we go, since we're already so close, if we go any more, it's going to be outside our interval. So these are all our answers. 7 pi over 12, 19 pi over 12, 11 pi over 12, and 23 pi over 12. Any question on this problem? All right. do question 30. So, solve square root of 2 sine x equals tangent x exactly on the interval 0 to 2 pi. So here, a helpful thing to do first is convert tangent to sine over x. Alright, and then we multiply cosine on both sides. Now we wanna get a 0 here so we could find our zeros, right? So we subtract sine from both sides. Now we can factor out a sine. So now we have answers where sine of x equals 0 or square root of 2 cosine of x minus 1 equals 0. Alright, so sine of x equals 0 in the interval 0 to 2 pi. We know that sine is 0 at 0 and also at pi. So we know that x is equal to 0 and pi from here. I'm sorry. Okay, so, and then we know from here, cosine of x is equal to 1 over square root of 2, which is the same as square root of 2 over 2. So now we've got to look on the unit circle where we have cosine at square root of 2 over 2. So that's going to be at pi over 4 and also at 7 pi over 4. And that will be all our answers. We could potentially have more if this interval was, say, 4 pi. Then you would have to like add an additional 2 pi to the answers. But in this case, it's just this. So always make sure to pay attention to the interval that it's in, because that changes your answers quite heavily. All right. Let's go on to question 31. So solve 2 sine squared x plus 3 cosine x equals 0 exactly on this interval. So here we can use our Pythagorean identity. To substitute in for that sine squared x so that we can have a common cosine x in this function so we can find what we need to find. Alright, so you go ahead and substitute that in. Alright, and now we distribute the 2. Alright. And now I'm just going to rearrange it a bit and multiply by negative 1/2 so that our leading coefficient could have a positive value. Or I mean, not negative 1/2, sorry, just negative 1. And so that ends up being 2 cosine squared x minus 3 cosine x. Obviously 0 doesn't change. So 2 cosine squared x minus 3 cosine x minus 2 is equal to 0. So with this, we can now factor. So we're going to have a 2 cosine x. We're going to have a cosine x. So we have to get a negative 3 cosine x. So we're going to have a negative 2, or some negative number and some positive number. We have to figure out which would be which. So we do it this way. Then you multiply negative 2 by negative 2 cosine. You get negative 4 cosine, and then plus a positive cosine. We do get that negative 3 cosine of x, and also these multiply to get negative 2. So when you factor, it's sort of just like reverse FOILing, you know. All right? And now we know that cosine of x can either be negative 1/2 or cosine of x is equal to 2. So let's find where we have values for negative 1/2. Looking at the unit circle again, cosine is equal to negative 1/2 at 2 pi over 3 and 4 pi over 3. Now 2, if you look at the unit circle, 2 is going to be outside of the range of cosine, because the range on our cosine is negative 1 to 1. So that means our answers are just 2 pi over 3 and 4 pi over 3 for this one. All right, any questions there? All right, let's move on to 32. So 32, solve the given triangle. So beta is equal to 109.8 degrees. Gamma is equal to 31.5 degrees, and A is equal to 22 inches. All right, so here we're going to want to use law of sines, because we have an angle, and we have its, or we can get an angle that has an opposite value, and the way we could do that is just by adding these and then subtracting it from 180, right? Because to do law of sines, you need an angle and then you need its opposite side in order to be able to do it. You need at least that. All right? So just write this: 180 degrees minus 109.8 degrees minus 31.5 degrees. So that's going to give us 38.7 degrees. So alpha is equal to 38.7 degrees. Now this triangle is clearly not to scale, because, you know, this angle is like the biggest one and the angle is like pretty small. And this is 109.8. So they might just draw a triangle like that just to like trick you. So don't worry about how the triangle looks, just worry about the measurements and what their associated lengths are. All right, so alpha is equal to 38.7. Now we could use law of sines. So sine of 38.7 degrees over A, which is 22 inches, is equal to, let's go ahead and find B first. Sine of 109.8 degrees over B. And doing that, I'll just write it like this. I'll write it completely. So now we can find C and B using good old Mr. Fish. I don't know if you guys are familiar with that term, but that's what I always heard in high school. Alright, so you essentially, it's basically just cross multiplication. So like to find B, alright, and B ends up being 33.1 inches. Alright, so B is 33.1 inches. Then we get C times sine of 109.8 degrees is equal to, yeah, we could do it that way, or we could just use the original one. But since I already wrote it like this, I'll just do it this way. But preferably, I like to use, to find the other side, I just like to use the original one given, because then you have less worrying about how many decimal places you use, unless you can like store that in your calculator. But in this case, I'll just write it like this since I started it. So 33.1 and we end up with 18.4 inches for C. And then alpha is 38.7 degrees. Any question of this problem? Alright, we will move on then. Alright, here is the balloon problem. So here, so hot air balloon is sighted at the same time by two friends who are 3 miles apart on the same side of the balloon. The angles of elevation of the balloon from the two friends are 11 degrees and 14 degrees. How high is the balloon? So essentially what this problem is asking us is to find this, h. Alright, so oftentimes we would use just like opposite over adjacent, so like sine of 14 degrees to find this. So sine of 14 degrees equals h over this. The only problem is that we don't know the length of this, right? So we can find the length of this using this triangle over here. And the way we can do that is law of sines. So first we want to find this angle, because we're going to need to find this angle since the only actual length we're given is this 3 miles. So first we find this angle. So these are supplementary angles, this one and this one. So we do 180 degrees minus the 14 degrees, and we're left with 166 degrees. Alright? And then we want to find this angle here. This is going to be a really tiny angle. And we know that all the angles in a triangle add up to 180 as well. So 11 plus 166, 180 degrees. 11 plus 166 is going to be 177. So that last angle is 3 degrees. Now we can find this length, right? So we do sine of 3 degrees over 3 miles is equal to, so we want the opposite of the x. So sine of 11 degrees over x, cross multiply, x sine 3 degrees is equal to 3 miles times sine of 11 degrees. Plug that in your calculator. And we get x is equal to 10.9 miles. Rounded. Alright, so now we're not done still. We can now use that to find h. So sine of 14 degrees is equal to h over x is equal to h over 10.9 miles. So then we get (10.9 miles) times sine of 14 degrees is equal to h, and h ends up being approximately 2.6 miles. Okay. Any question on that problem? All right, awesome. So here we go, guys. This is the last problem. All right, so solve the given triangle. A equals 3, C equals 7, and beta equals 55 degrees. So in this case, we can't use the law of sines because we don't know the opposite length, or the length of a side that's opposite to an angle. So if we draw out this triangle, it's not going to be to scale. Say this is 55 degrees, and that's beta. So that means this is B. And then we have A is 3. So I'll say this is alpha. And then I'll say this is gamma. So something like that. Just to get a visual. So we can use this to find B, since we have this side, this angle, and this side. So we can use the law of cosine. So b squared is equal to a squared plus c squared minus 2ac times the cosine of beta. Now I can just plug in those values. And we get b squared is equal to 33.90979. So b is equal to plus or minus 5.8232. Except we know it's got to be a positive value since it's going to be a length. So this would just be, I'll just go ahead and round now, so positive 6. So I don't have to write that all out again. Alright, now that we have b, we can now use law of sines since we have the angle that is opposite of that length. Alright, so now what we can do is take that, sine of 55 degrees over 6, and we can use it to find angle alpha. and angle gamma. So let's do this, sine of alpha over 3. Sine of 55 degrees is equal to 6 sine of alpha. Sine of alpha is equal to 3 sine of 55 degrees over 6. And we know alpha is equal to the inverse sine of that whole mess there. So we end up getting 24.17820 degrees, which is approximately 24 degrees. All right. And now we can use that angle, since we have another angle, to find gamma, using our knowledge of triangles having a total angle of 180 degrees. So we can do 180 degrees minus 55 degrees minus 24 degrees equals 101 degrees. So, and that's gamma. All right, so gamma equals 101 degrees, alpha equals 24 degrees, and b is equal to 6. And those are our 3 answers. Or we have everything solved for triangle. We have a, c, b, and we have alpha, beta, gamma. All right, any question on that problem? All right, well, that was our last problem, guys. So you have any more general questions for me or for about the exam or anything? No? All right, then. Well, I wish you the best of luck on the exam. Hopefully this was helpful. This isn't completely comprehensive. I can't cover everything in 2 hours, so this is not like a replacement. So definitely still study hard for that exam. Get that A if you still can. All right, guys. Take care, though. Have a great day. And good luck on your other finals as well. Yeah.
Professor Lawson wrote an announcement. He said how I was pretty sure at least how he said 5.5 is not going to be used in the final since it was in test 3. But I'm not sure exactly.
Oh, it's not?
He didn't say anything about it today, so I'm not sure. Like it was in
Oh,
the past announcement.